So everything we have discussing so far, we have been discussing all the use cases we have mentioned, it's all application integration. And we say the application integration is the process of enabling independently designed application to work together by exchanging real-time message or data through API calls or events, and this is to support business processes. So for example, one more example, I am a customer who wants to subscribe to a telecom company. So once I go and sign up, I want to automate the end-to-end process. I put my details, I get a SIM card assigned to me, I get a number assigned to me. This is provisioned in multiple systems, end-to-end. It's getting applied to the CRM. I have it's created on the billing system. It's created on the charging system, end-to-end. So this is where we get a streamlined process if your system allow. Another type of integration is data integration. And by the way, if you get any questions, feel free to post it. We have a question and answer section, or you can post it in the chat to avoid forgetting it. The other type of the integration is data integration. Data integration is different by all meaning. It's different in the context, it's different in the component, the runtime, and everything. The way we define data integration, we say the process of consolidating, transforming, and loading data from multiple sources into a centralized data store. For what purpose? For reporting, for analytics, for operational use. And I cannot tell or emphasize more the fact that for AI, for machine learning, all the hypes recently happening, it's useless without data. So data integration, let's have a deeper look into this one. Let's say I have two more use cases here. Again, it should feed back into cost optimization, operational efficiency, benefit realization. There's two use cases. Let's say customer 360 view. Simple. You log in today to Amazon. You have been purchasing items for last few years, and suddenly you find Amazon is popping with recommended items. Apple TV does the same, recommended items. Wherever you go, you get recommended items. Even you might be sitting on the platform on YouTube watching a video, and you go to Facebook and you find recommended items. So how is this even possible? This is all about data. So one of the great use cases I have seen in the data field for the customer 360 view was Levi's. If you guys know Levi's, it's a clothing company. And what they have done, they managed to collect the data from all the customers and where are they from, how the weather look like in each of their countries, at which time of the year, and they blend all together in a machine learning model to propose what is the best treatment for our customers. So one customer could be so happy to receive a gift, but they invited another customer to have a tailored jeans for him because they realized that this guy would have like more important VIP experience and having something very specific for him, as opposed to someone just happy with getting the gift and that's it. So building this customer 360 view, it's everywhere. It's like even telecom company started to build the same thing. Any shopping or e-shopping experience now is filled with a customer 360 view. And this is in the private sector. But if we take customer out and we put a student, it becomes very important to have a student 360 view. If we take it out and we put patient, it's very important to have patient 360 view. The fact that there is no one system or application hosts all your data. It's always scattered because it's a billing system versus hospital system versus XYZ. And this is where integration or data integration fits in to get all these data consolidated together and run operation. And I'm not talking here about data. So a lot we can talk about data. We can talk about data quality, governance, stewardship, all these kind of nice rules that ensure the data is valid and accurate and timely. But I'm talking here about the fact that only about integrating these data together. We'll see later technically what does it mean differentiating between application integration and data integration. Another example that can save lives is patient data. So I've been looking yesterday into an example of a lot of data has been came together and through machine learning tools to predict the cancer. And based on these data, they were able to discover very early stage when they do scans and analysis to other patients if they are high likely to get cancer or not. And this is not something new again. I mean, AI and machine learning and data has been there forever, but it just became hype for different reasons. So the way to integrate data, it's just another very crucial, important part. And we can talk again forever about it. But again, I'm just want to emphasize the fact this can happen manually. This can be automated. It's called data integration. So your integration can be downloading the file from here and upload it to here. It's a manual. It's integration. You're exchanging data between two systems. But then it becomes a proper integration when you inject it into automation. So these are two examples of the data integration. And yeah, this will take us to the next discussion into the architecture view, how these things are technically different. After we addressing the need for the integration, how do we articulate the value for the business, different types of integration across public and private sector. Okay, so now talking about the integration architecture view. Technically, what does it mean really? Again, the definition doesn't change. It's at its core, it's integration, the ability to exchange data between two or more components. And the reason I'm saying components, because components can be physical, it can be logical. It can be physical like devices, it can be logical like systems and applications. And this is another problem where integration is just designed or like summarized into APIs or a file transfer, losing all the big insights. So I will give you example. In telecom companies, they always have something called logical inventory and physical inventory. So when we talk about logical and physical inventory in telecom, what does it mean? You will find that it's a very interesting concept I've experienced it myself. With a physical inventory, it will tell you, for example, there is a router. This router has this number. It's sitting on room number 2 in the second floor in the building, this building in this street, the street in this city, the country. This is exactly the identifier and the physical inventory to a device. And the port where this router is connected to is XYZ. This router is connected to a home router which lives in this street, in this place exactly, in this suburb. And they are connected through a physical connection, let's say fiber optics or like optical cables. This is what we call a physical connection, which comes to the physical inventory. The logical inventory becomes what service we run on the optical. And this could be simple as broadband, for example. So similarly, when we talk about connecting multiple components, exchanging data, we are talking about, is it physical or is it logical? Is it application and systems and services or is it devices? Okay, so let's look at that. We have 3 elements to address in the integration architecture side. Let's start with this one, the integration types and service view. And then we'll talk about how the integration at scale works, and we'll address also the third element. So integration types, we discussed application integration and data integration. From the summary we had, the purpose of application is real-time process coordination or transactional data. I'm making a payment. Payment is getting done on the Wind Cave, let's say, or any payment gateway. The same transaction need to go to my billing system on a general ledger. It's application integration. In data integration, it's far more. It's my data as a customer, all my data as a customer, regardless what I'm doing, buying or selling or whatever I'm doing. It's all consolidated into one place and running through machine learning or something to do some recommendation. So the ability to collect my data from different systems, make it available in a centralized place, it's a data integration. We'll take more examples. We can talk more about data integration. It's very, very common. Let's say the road traffics in any modern cities, they are all equipped with IoT devices, Internet of Services kind of thing. And they are all sending a huge amount of data, gigabytes of data. And they are just streaming all data somewhere to understand the traffic, how things went fine or wrong, etc. So data has so many applications. And this data volume is very small transactional in integration, but it's a very large scale horizontal data. This is where a car like Tesla, by the way, Tesla as a company, it's defined as a data collection company. The company is going through the roads all the time and just capturing and taking screenshots and etc. Some Tesla has hardware inside Tesla itself. It's what we call edge computing. And then they have their own storage. This storage sends back to the cloud. But if they get the car connected directly to the cloud, it's a risk, of course. It's slow, it's blah, blah, blah. But then putting the cloud edge due to the large scale of the data is getting embedded into cars or flights, etc. The latency is low, milliseconds to seconds. You cannot go to make a payment in Wind Cave and you wait 5 minutes to get it done. It should be very low, milliseconds. In the data, while you are getting the transaction done fast, in the background, the process can take longer because it's a high volume. Typical flow for application like API-based, event-driven, we can talk about file integration, etc. In the data integration, it becomes like a batch or streaming. So streaming is like, for the non-technical people, it's a place, let's say it's a queuing mechanism where you publish all your data in one place and then it becomes a hub and someone listen to it and just keep capturing this data. We'll explain it on whiteboarding in a few minutes. And then example, we say for applications like CRM and ERP, but data integration is mainly relying on what we call a method called ETL. Which is extract, transform, load. Extract data from the source, transform the data to make it ready for consumption by the destination, and then load it to the destination. This can be different, can be ETL, and then can be ELT, like I will extract first, and then I will load it to the new system, and the new system will take care of it and transform it. Different abbreviations, same method, but just who's the owner of what. The T is the key, who's doing the T. So from a technical, I'm just giving here example from Azure environment, and it can be anywhere else. It can be in other environment as well, or like MuleSoft, or like Oracle, or AWS, whatever. But just as example from how the pipeline might differ. They are completely different technologies. So you'll see here Azure Integration Platform, and has this flow. I will explain it soon. And then we have this here is the ETL. If you look at this diagram here, we find this system. Let's say we have a system 1. And system 1 needs to talk to system 2. The question we ask usually, what is system 1? How do you define system 1? What does it mean? And people might say, okay, system 1 is a platform that lives on the cloud or on-premise, and it provides multiple interfaces. Let's assume in this case, it provides HTTP interface. HTTP is just a REST endpoint. So it can be file integration based, it can be API. And I don't want to go too deep technical in what is API now and what is file integration, but yeah, on a high level, this is where I will get the data as HTTP request. And then we have the processing layer, whatever happens in there. And then we have S2, and this is system 2. And let's assume the system is legacy. And because it's legacy, it doesn't have any mechanism to connect. It doesn't have API, it doesn't have file integration. Let's say it's just a database. So we decided to add it onto SQL database, and then we will replicate the data later. And this could happen. This is example of things that we try to integrate, but we fail to integrate because of some issues. If you look at here, you find this logic apps and this function here. There are two components allow you to write a simple code to orchestrate multiple services or connect to multiple applications to exactly perform a simple transaction. So again, let's say system 1 is your front end. You make a purchase from an e-commerce. You want to do a payment. So you send the requests from S1 through HTTP to S2. Let's say S2 is a billing system. And then you have a payment gateway or something. So let's say we have another system here, which is payment. And then this system is a billing system. So Logic Apps, what it does actually receives the request, go to payment, do the actual payment, go back, continue, send a general ledger transaction to the billing system, and come back with successful message. Your payment is done and all good. So simple. Similarly, all the application integration. On the other hand, the data can be quite different. So if you see here, data is capturing a list of data, multiple log files, unstructured media, structured and unstructured, whatever. It doesn't have HTTP request. It doesn't have file integration at the beginning. But what does it have? This is your main best ingest, which is, let's consider this is the E. We agreed ETL, right? And let's say this is a load. And it doesn't have to be one load. We can have load here and load here, whatever, right? And then let's say somewhere here, we are going to do the T, transform. So the fact here, it's not exactly the same. Just don't get me caught into what each of these services. It's a different story. But what you see here is we collected a lot of data. We managed to ingest it. We did transformation. We loaded also to Azure Data Storage or Databricks, and then we make it available for Power BI for analytics. You might run machine learning. You might run other solutions to play with the data, etc. So they address two different use cases. But then let's assume you loaded your data in Azure Cosmos Database. It becomes a central place for all your customer data. So when I join as a customer here to my web application, I will be able to load all the products I purchased, my experience, recommended products, personalized experience, everything. It's not all here by default. It's all came here. And this is what we call data pipeline. It's a very, very crucial part of integration.